This is part 3 of 4 parts are from a presentation given at the Australian System Safety Conference 2018, ASSC 2018, Melbourne, Victoria, Australia. Essentially, this work looks at the ideas behind case notation literature, which has deliberately averted gaze from goal-oriented requirements engineering and its notations. The approach discussed in this presentation is not part of Raytheon Australia proprietary limited policy, process, procedure or practice. Stirring the pot. A demonstration of non-monotonic reasoning, framed by normative heuristics, to attain a methodological approach to achieving epistemic high standards. Despite previously arguing rationale is not argument, we now argue that argument is rationale. Per Rushby's observation about the role of rationale, can a case notation be used for rationale? Habley, Wu, Atwood, and Kelly claim to extend goal-oriented requirements engineering with argument and argue quality attribute scenarios from Carnegie Mellon are goal-oriented and that they display qualities of Zave and Jackson's SK entails are, aka knowledge frames. The experiment. Starting with the example in Habley, Wu, Atwood, and Kelly, we will 1. Model the quality attribute scenarios, QAS, graphically, instead of by tablature. 2. Add so-called antigoals. 3. Include anti-antigoals to capture the mitigations for the antigoals. And 4. Capture a goal-satisficing argument over a tree, a familiar structure to proponents of GSN, using QAS reasoning fragments. We will go no deeper than the original example by Habley et al. To be a fair comparison. Do take notice, however, that we will move towards a graphical intent specification in user requirement notation or URN, and also show how case reasoning falls out of the modeling of requirements in goal-oriented requirement language or GRL. Quality attribute scenarios, or QAS, in GRL are straightforward. While generally captured in instrument tables, note the graphical analogy is readily interpreted in GRL. Note also the analog of QAS in Anticipatory Failure Determination Approach, AFDA. That is, the QAS model appears to be an analog of the notions within AFDA of SEOR, source, effect, object, and result. AFDA has roots in research and application back to 1960. The interpretation of QAS in GRL includes native use of GRL's KPI notation. KPI are a standard means of setting objectives and documenting the degree of attainment of objectives. This is a means of setting validation criteria. This is useful over the QAS model, as this is part of the QAS model supporting the concept of SMART, being, S for specific being targeting a specific area for improvement. M for measurable being quantify or at least suggest an indicator of progress. A for assignable being specify who will do it. R for realistic being state what results can realistically be achieved, given available resources. T for time-related being specify when the result, S, can be achieved. Thus, setting up design decisions, and not just requirements for assurance. Importantly, this approach recognizes the Jensen-style sequent calculus afforded by problem frames. Problem frames being of the set of concepts Zave and Jackson have proposed and presumably also vindicated by Habley et al. The notion of a piecewise proof over the graph helping us to deal with inductive reasoning, since the sequent calculus provides a validated closure mechanism for reasoning over open sentences. At this point, note that the hazard presents a negative contribution to the intended function. That is naturally quite an intuitive relationship. When introducing the notion of antigoals, there is a need to modify the logic somewhat. The antigoal is now the element that works against the function. That now means that the original failure mode positively encourages the antigoal. This is again quite an intuitive notion. We are now seeing the backbone of dialogical reasoning. This points also to the problems with case notations, as elaborated by case notation literature. Is the world of goals really black and white? Are antigoals a stab at defeasibility or at rebuttal? Did we not reject rebuttal semantics in GSN when ignoring Tolmin? Go further, provide anti-goal. Add a design decision that counteracts the failure, and that intends to avoid the anti-goal. Think of this as a petite argumentlet. If we are encouraged to move to anti-goals, why not agents versus anti-agents? Would you believe, I*-style notations, the notation that GRL is derived from, are also used in security modeling? Would you believe then that using a lightweight promiscuous goal-oriented requirements engineering notation, that includes agent formalisms, means you can attempt and perform an agent-oriented STPA safe sec? We can then repeat the QAS-style reasoning over other concerns. Note here that tool support for GRL includes algorithms that set the level of satisficing in the dialogical argument, read for the anti-goal meaning it is not satisficed. Of course, with all concerns mapped onto the same diagram, we achieve a visual context model that is self-evident. This throws up a challenge to the notion that context is a bubble in a notation's lexicon rather than a concept. Facilitating the agent-oriented argument simply then requires providing a top goal or claim. Note the tree, there is something about trees. Note the monological part-whole decomposition of goals, being the archetype of the solved by relation of GSN. Note that it is easily mixed in with the dialogical contribution relationships. Note also the dialogical reasoning is intention versus unintended in the etiological sense, and then somewhat akin to Holgel's ideas of good things and bad things coming from the same place. Given the discussion within the GSN literature around problems for comprehension of safety case arguments, is there an argument that GSN is information lossy, with respect to the design representations? That is the problem for comprehension of GSN arguments a side effect of its limited semantics? Is the problem for GSN that it only witnesses the design, and does not participate in the design? The challenge for the reader, start at the GSN representation at the right and get back to the model at the left. Of course, when we heed the warning by GSN practitioners that Tolmin notation, having been designed to be completely general, does not explicitly capture concepts that relate to the safety domain, such as system models, then we must reject GSN on that same basis. Since Hablee et al. Rely upon vindication by Zave and Jackson, it makes sense to note that Zave and Jackson propose that agent formalisms have all the recommended expressive capabilities for modeling of control information to attain soundness in requirements engineering. Therefore, goal formalisms alone do not have all the recommended expressive capabilities for modeling of control information to attain soundness in requirements engineering. This then challenges the role of GSN in requirements engineering. Note also the hitch proof for use of QAS heuristics when modeling in GRL. It reads, since QAS entails knowledge frames, and each safety concern was closed using QAS reasoning, the top safety claim is met because it is entailed by the combination of the three closed safety concerns. The best evidence that GSN can only be used to witness the design is the admission by Hablee et al. That requirement validation is outside of the GSN model. In comparison, support for requirements validation is a stated design goal for ITUTZ 151 user requirements notation. In ITUTZ.151 actors, goals, requirements, features, aspects, and tactics provide a normative taxonomological basis to act as an architecture description terrain. Justification for actors, goals, requirements, features, aspects, and tactics can thus provide a normative assurance argument terrain. The range of epistemic standards addressed by semantics in ITUTZ.151 can supply that embedded justification. IEEE 40-2010 Systems and Software Engineering Architecture Description includes goals describing the nature required of rationale supporting architectural descriptions. ITUTZ.150 can act as the requirements for a notation that satisfies those IEEE 40-2010 goals. ITUTZ.151 acts then as a reference design for the language specification. That the semantics of argument, as described by IEEE 15026 System and Software Assurance, is a subset of ITUTZ.151 means ITUTZ.151 also acts as a bridging standard between IEEE 42010 and IEEE 15026. This acts to amplify embedded architectural rationale into assurance claims where the rationale addresses system quality attributes and their trade-offs. The goal-oriented nature of ITUTZ.150/151 also threads goal-oriented rationale into the architectural description to meet the intent of intent specifications, since both come from the same cognitive science basis. This might therefore meld York and MIT thinking into a unified model of agent-oriented assurance cases, with nothing more than a meme shift. More formally, there are a raft of academic meme channels that present themselves as disparate, but in fact cognitive science can account for the manner in which goal-oriented thinking can be applied to causal logic concepts, as they relate to requirements modeling, through formal specifications that can express those goals mathematically, to the notion of means. The notion of means borrowed from the taxonomy of dependable and secure computing as proposed by Aviciennes, Laprie, Randall, and Landwehr. Those means being the archetype of the notion of architectural tactics, and therefore the basis for design decisions. That is, we can weave assurance reasoning from top to bottom using dialogical reasoning in our requirements and architectural descriptions, suitable for preliminary and architectural justifications, without having to stalk the design artifacts with a second, clumsy monological semantic network. Thank you for your consideration of this presentation. Enquiries are welcome via ResearchGate.